Hello students, in this session we will discuss moment area method. In previous session we discussed introduction of moment area method and we calculated one numerical. Now in this session we will solve one numerical to calculate slope and deflection of cantilever beam which is carrying point load. Here we need to calculate slope and deflection at free end of a cantilever beam using moment area method. So in this figure you can see that this is the given cantilever beam AB. Total length of this beam is 6 meter and beam carries one 10 kilonewton point load at point B which is 6 meter away from point A. The beam also carries another 10 kilonewton load at point D which is 4 meter away from point A, and the beam also carries one 5 kilonewton load at point C which is 2 meter away from point A. The beam has free end at point B and fixed end at point A. Given value of Ixx, which is moment of inertia, is 2 into 10 raised to 8 mm raised to 4, and value of capital E, which is Young's modulus of elasticity, is 2 into 10 raised to 5 Newton per mm square. Here, flexural rigidity of section AC of the given beam is twice than that of section BC. So, as we did in a previous session, here again we will follow the similar steps. In step number 1 we will calculate moment and then we will draw bending moment diagram and M upon EI diagram, and after that we will determine slope and deflection at point B. So let's start with our step number 1. In step number 1 we will calculate moment. Here we need to calculate moment at point B, D, C and A. And we know that moment at free end of cantilever beam is 0. So moment at B is equal to 0. Now let's calculate moment at point D. Here this 10 kilonewton point load will generate clockwise moment about point D, and we are calculating moment from left hand side, so we will consider all clockwise moment as negative. So moment of this 10 kilonewton load up point D is equal to 10 kilonewton, which is load, into 2 meter, which is distance between line of action of this 10 kilonewton load and point D. Here negative sign indicate that the generated moment is clockwise in a nature. So we are getting moment at point D, MD is equal to minus 20 kilonewton into meter. Now let's calculate moment at point C. So here both 10 kilonewton point load will generate moment about point C which is clockwise in a nature, and we will consider clockwise moment as negative. So moment of this 10 kilonewton load at point B about point C is 10 kilonewton, which is load, into 4 meter, which is distance between line of action of this 10 kilonewton load from point C. Similarly, moment of this 10 kilonewton load at point D about point C is equal to 10 kilonewton into 2 meter. So total moment at point C is equal to minus 60 kilonewton into meter. Now moment at A. So all this 3-point load will generate clockwise moment about point A. Moment of this 10 kilonewton load about point A is 10 into 6. Now moment of this 10 kilonewton load about point A is 10 kilonewton into 4. And moment of this 5 kilonewton load about point A is 5 into 2. So total moment at point A is equal to minus 110 kilonewton into meter. Now let's draw bending moment diagram. So here is bending moment diagram. So at point B moment is 0. So here it is 0. Now at point D moment is 20 kilonewton into meter. Okay, so I mentioned 20 kilonewton into meter over here. Now in between point B and D there is no load. So bending moment diagram will be straight inclined line. Similarly, moment at C is minus 60 kilonewton into meter. Again, in between points C and D, there is no load, so bending moment diagram will be straight inclined line. Similarly, at point A, moment is minus 110 kilonewton into meter. Again, in between point A and C, there is no load, so bending moment diagram is straight inclined line. Okay, so this is bending moment diagram. Now, let's convert this bending moment diagram into M upon EI diagram. M upon EI diagram is similar to bending moment diagram, but the only difference is that instead of considering moment M, here we are considering M upon EI. So, let's draw M upon EI diagram. So, here this line with all 4 points and relative distance between them. Now, at point B, moment is 0. So, M upon EI will also be 0. Now, at point D, moment is 20 kilonewton into meter. So, M upon EI will be 20 upon EI. Now, in between point B and D, there is no load. So, line will be straight inclined. Now, at point C, for section CD, at point C, moment is 60 kilonewton into meter. So, M upon EI will be 60 upon EI. Again, in between points C and D, there is no load. So, bending moment line will be straight inclined line. Okay. Now, here I am converting M upon EI diagram between points C and D into two different shapes for calculation purpose. So here you can see that I divide M upon EI diagram between points C and D into two shapes, one rectangle and one triangle. So here I am extending this line from point D. So here depth of this rectangle will be 20 upon EI and height of this triangle 60 minus 20 is 40 upon EI. And base of this rectangle and triangle is 2 meter. Okay. Now, in section A to C, flexural rigidity is twice than that of section C to B. So here at point C, bending moment is minus 60 kilonewton into meter. So here for section AC, particularly for point C, if I consider M upon EI, then it will be 60 upon 2 EI. So at point C, M upon EI will be 30 upon EI. Okay. Now, at point A, moment is 110 kilonewton. So I consider M upon EI, then it will be 110 upon 2 EI, which is equal to 55 upon EI. Again, in between point A and C, there is no load, so bending moment line will be straight inclined line. Here, again for calculation purpose, I am dividing M upon EI diagram between point A to C in two different shapes, one rectangle and one triangle. So here, depth of rectangle is 30 upon EI and height of this rectangle is 55 minus 30, which is 25 upon EI. Okay, so this is M upon EI diagram, and for calculation purpose I gave number to each shapes. Okay, now let's move to next step, and in this step we will calculate slope at point B, and I denote it as theta B. Okay, so here we will apply moment area theorem 1, and as per moment area theorem 1, equation to calculate theta B is equal to minus area of M upon EI diagram between point B and A. Okay, so here you can see that in M upon EI diagram there are total 5 different shapes, and for calculating slope at point B, we need to calculate area of each shape, and then we need to add all the areas to get slope at point B. Okay, now theta B is equal to area of this first shape, as it is rectangle, so area will be B into D. So B is 2 meter and depth of this rectangle is 30 upon EI. So area of this first shape is 2 into 30 upon EI. Now area of second shape, which is triangle, it is 1/2 BH. Okay, so 1/2 base of this triangle is 2 meter and height of this triangle is 25 upon EI. So area of this shape is 1/2 2 into 25 upon EI. Now area of this third shape, which is rectangle, is B into D, which is equal to 2 into 20 upon EI. Here you can see that depth of this rectangle is 20 upon EI. Now area of this fourth shape, which is rectangle, it is 1/2 B into H. So it will be 1/2 2 meter is a base and height of this rectangle is 40 upon EI. Okay, and now area of this last shape number 5, which is triangle, is 1/2 BH. So it will be equal to 1/2 2 meter is a base and height of this last triangle is 20 upon EI. So if I calculate, then I will get theta B is equal to, here area of first shape is 60 upon EI. Area of second shape is 25 upon EI. Third shape is 40 upon EI. Fourth shape is 40 upon EI and fifth shape is 20 upon EI. Okay. So I am getting theta B is equal to 185 kilonewton into meter square upon EI. And here value of capital E and capital I in Newton and mm unit. So we need to convert 185 into Newton into mm square. For that we need to multiply 185 with 10 raised to 9. So if I multiply 185 in 10 raised to 9, then it will be converted into Newton into mm square. Now value of capital E, which is given, 2 into 10 raised to 5, and value of I is also given, which is 2 into 10 raised to 8 mm raised to 4. So I am getting value of theta B is equal to 0.0046 radian. Now let's move to next step. In step number 3, we will calculate deflection at point B and I denote it as YB. Here we apply moment area theorem 2 for calculation of deflection, and here is the equation to calculate deflection at B, which is YB is equal to minus moment of M upon EI diagram between point B and A about point B. So for calculating deflection at point B, we need to take moment of all this 5 shape about point B. So let's start with shape number 1. Area of shape number 1 we already calculate. In step number 2 it is 60 upon EI. Now moment of this shape number 1 about point B is nothing but area of shape number 1 into distance of CG of shape number 1 from point B. So distance of CG of this shape number 1 from point B is equal to 4 meter, which is distance between points C and B. And distance of CG of shape number 1 from point C is 2 by 2, which is 1. So total distance of CG of first shape from point B is 4 plus 1, it is 5. Now let's take moment of second shape about point B. Again it is area of second shape into distance of CG of second shape from point B. Area we already calculate, it is 25 upon EI. Now distance between B and C is 4 meter. Here you can see that it is 4 meter. Now distance of CG of shape number 2 from point C is 2 by 3 into 2. So here is the moment of second shape about point B. Now moment of third shape about point B is area. Area we already calculate, it is 40 upon EI into 3. 3 is the distance of CG of shape number 3 from point B, which is 2 meter plus 2 by 2, so it is 3. Now Let's move to fourth step. Area of fourth step as we calculated is 40 upon EI and distance of CG of fourth shape from point B is 2 meter plus 2 by 3 into 2. Now last shape number 5, moment of shape number 5 about point B is area into distance of CG from point B. Area as we calculated it is 20 upon EI and distance of CG of this shape about point B is 2 by 3 into 2. So if I solve this then I will get YB is equal to 713.33 kilonewton meter cube upon EI and I am converting it into Newton into mm cube. So if I calculate, I am getting YB is equal to 713.33 kilonewton into meter cube on EI. And for converting it into Newton into mm cube, I am multiplying 713.33 with 10 raised to 12. Value of E and I which is given 2 into 10 raised to 5 and 2 into 10 raised to 8. So I am getting YB is equal to 17.83 mm. Here I am getting YB means deflection positive. It means the beam is deflected in downward direction. This is end of this session. Thank you.